The sensations in a spin are confusing, and this is sometimes the greatest danger.
The forecast is calling for variable cloudiness and warm with highs in the 90s this afternoon, lows tonight in the 70s, highs tomorrow again in the 80s to near 90 degrees. Under partly cloudy skies, it is 82 degrees on the outside, humidity at 50%, the winds are light and variable, visibility is 6 miles in haze, and the barometric pressure dropping. High tide expected at Point Lookout at 1:16 and at Cedar Point at 1:50 this afternoon. 82.
The commander of a base knows its workings, inside and out. He knows what it takes to make it run.
Down below us lies the Naval Air Test Center, Protection River, Maryland. Different from any other test activity that the Navy has, because this is the only air test center where we test and evaluate the complete airplane and all of its components. In those hangars and laboratories, we find the 3 operating test divisions: flight test, service test, and weapon systems test. And perhaps the most important of all, the U.S. Naval Test Pilot School. There's some very unique facilities here. Catapults and arresting gear just like aboard ship. 3 seaplane basins, the Anti-Submarine Warfare Tactical Support Center, 12,000-foot runways, airspace to 85,000 feet, and other assets for a good test activity. My job is more or less a coordinator's job, since we do have the test divisions who do their part of the overall test plan. When that particular test plan calls for a missile testing at Point Magoo, then I put on my other hat as the coordinator of test and evaluation for the Naval Air Systems Command and coordinate the guided missile part of it along with the NATC portion of it. The test pilot is the key man in the whole concept of an integrated test program.
The spin is usually a violent maneuver, and the cockpit forces are very high. Spin testing is classified as hazardous testing. For this reason, a great amount of advanced preparation is necessary to see that spin testing can be conducted in the safest possible manner. Of course, we try to make sure that the spin pilot and everyone concerned with the spin program has a lot of experience and has really done their homework, because it is possible to lose an airplane. The man who makes up the other half of the team in this project is a graduate mechanical engineer whose specialty is an airplane's flying qualities and performance. In a spin program, we don't like any surprises. Most of the technical problems can be predicted by calculations, and the engineer has a good handle on these. The concept of the test pilot engineer team is carried through in most of the other areas of the test center's activities.
Marv, what do you think we ought to do today on this hop?
Well, on this particular hop, we'd like to be looking at the recoil adapters. We'd have strain gauges mounted in the critical points of the turret, and we'd like for you to fire full complement. Now, on these particular adapters, we have 13,000.
The test pilot is going to perform the final phase in the testing of the gun system, which began in the firing tunnel. Take the ship and fire the entire complement of the magazine into the cannibal target. When the pilots in combat receive the aircraft and gun system, they will have the confidence that this is the finest gun system that the services have to offer. and know that it has been tested properly and thoroughly here at the Naval Air Test Center Production.
The heads-up display is the first of a series of electro-optical aids that we're going to see in the future years of aircraft development. The HUD is reflector glass that's put up in front of the pilot. We can portray on this glass things like airspeed, altimeter, magnetic heading, and the attitude of the aircraft.
Much of naval aviation takes place aboard aircraft carriers. It follows that a good naval air test facility must have the equipment which can simulate at-sea conditions. Test pilot engineer teams use these tools, evaluating hardware like the head-up display system to see if it can withstand the heavy G-forces at launch and landing aboard ship. Working together, a pilot and engineer devise a test plan. They execute it, and then collaborate on a final written report.
The relationship between the test pilot and the engineer is a very close relationship. The test pilot identifies the problem and points out possible solutions for the problem. And the engineer comes up with the mechanization, the mathematics, the ability, the know-how to solve the problems that the test pilot finds.
I think we're going to have to reverse that possibly. What do you think about that?
Well, this is one of the problems that we are finding out. The angle of attack indicator is completely 180 degrees out of everything else on the HUD.
Post-flight evaluations are very important because it lets the engineer know what the pilot has seen during his flight. And the engineer can sit down, think about these things, and plan how he will look at them or how he will have the pilot look at them on the next flight.
Let's take a look at the approach for our landing footage. I want to show you a problem I think we have in there. Okay, see right here how the angle of attack bracket is jittering up and down? That's very confusing. We're going to have to find some way to damp that out.
That's been a problem that's been noticed before. The other pilots have reported on it. As far as I know, the contractor is working on it.
Tell you what, run a little more footage. I want to show you another problem in here. Okay, see right here, I'm getting slow, and the angle attack indicator's climbing.
After a system like the HUD has been thoroughly evaluated, and the results have been reviewed and analyzed in the Technical Support and Computer Services Divisions, the Center's two support activities, the job is still not finished. The Center's own test pilots will then take the equipment out to the fleet and give it additional shakedowns.
We're also putting symbols into the HUD for the pilot to aid him to get his weapon to the target effectively. At times, even a head-up display will not solve a problem that all pilots occasionally face, and that's a faulty weapons release systems design.
Faulty bomb and rocket designs are very serious problems that the Test Center has been working hard to solve before they appear where they hurt most, in combat. Things like poor aerodynamic stability and bomb-to-bomb and bomb-to-aircraft collision cause unpredictable trajectories where only one bomb may reach the target. Other things like large aerodynamic forces can actually lift the weapons and cause them to strike the horizontal tail of the aircraft. A simultaneous release, not only is the tail in jeopardy, but other weapons may be struck and damaged as well. The danger in bomb-to-bomb collisions is very shortly after release, the fuse is armed, and any collision will cause the bomb to detonate and others to detonate sympathetically. This could spoil the pilot's whole day. Rockets, when fired at close intervals, cause numerous rocket-to-rocket collisions and erratic trajectories. These collisions may cause the rocket to break up or to shed fins. This debris can be ingested by the aircraft's jet engine and cause severe damage. Even in this critical test to evaluate rocket breakup, we did not lose an aircraft. As a matter of fact, we have not lost an aircraft during any previous weapon separation testing. Near the end of motor burnout, the trajectory is erratic, and the rockets move in a corkscrew fashion. This greatly increases the dispersion, which reduces the warhead effectiveness. It is better to discover problems like these here at the test center early in development than to correct the situation after deployment.
The problem with survival is that time runs out.
Patuxent is concerned with more than just hardware. It's deeply involved in all aspects of pilot survival, from safety systems built into the aircraft to pilot rescue after a plane has been downed. The Global Rescue Alarm Network utilizes a miniature radio that can access a satellite more than 22,000 miles away. The test center is currently developing this system, called GRAN, for the military.
The Coast Guard spends 98% of its time in search and 2% in rescue. They feel that if we could give them a 40% chance of one locus and a 60% chance of another locus, they could practically invert those statistics.
When operational, the GRAN system will be able to find ditched pilots, hunters lost in the forest, or accident victims wherever they're located.
We feel it's a service that the United States could offer to the entire world. No voice is necessary. There is no language barrier in this rescue system. Likewise, distress knows no nationality, and survival knows no ideology.
Before any Navy flight can begin, whether a spin test or a combat mission, it must be thoroughly checked out. But who evaluates the reliability, performance, and suitability of the ground support equipment? Acting almost as a miniature Bureau of Standards, the test center will investigate all of an aircraft's ground support and servicing equipment. Before obtaining a Patuxent approval, this gear must equal or surpass the Navy's stringent requirements. A unit like the borescope, which will enable the Navy to save thousands of dollars in time and money, is used and reused under fleet conditions. The borescope is a device which incorporates fiber optics. It gives a Navy mechanic the ability to get inside a jet engine and diagnose problems such as fractures or hot spots without having to pull the engine.
John and I are the test project pilot and test project engineer on the program.
What we do when we go to the contractor facility is review his program progress, review his designs, review his proposals to see if they're staying within the bounds of the government-furnished contracts.
Patuxent is able to save the Navy money and time another way, by ironing out problems with a contractor before they begin. Test center teams, made up of test pilots, engineers, and naval flight officers, will travel to a contractor's own facility to advise and consult with the people involved while new equipment is being developed.
Chafing clearance there is adequate. However, we can have them take another look at it and see if
we talk to his engineers, and if I find something in the drawing that I don't think is exactly right, then we get together in conference this particular item. This sometimes carries over for 3 or 4 days, and then the end result is a solution that's acceptable to everyone.
I think we're well within the spec here, which was a prime consideration because of the close proximity there to the fuel line.
The airplane itself is instrumented so that certain data can be telemetred to the ground. so that the project engineer himself is aware of what's going on in the air during the test. Such things as airspeed, altitude, bank angle, roll rates, yaw angle, yaw rates, turbine inlet temperatures, also the RPM type information.
The use of sophisticated recording and telemetry equipment in naval air test projects led several Patuxent engineers to propose a new and innovative idea in the field of anti-submarine warfare.
The concept of the Tactical Support Center originated here at the Naval Air Test Center. All of the background information came from our involvement in the P-3C ASW airplane. The P-3C is a fully digital, automated airborne system, and we recognized the need to have a ground-based automated system to support this P-3C aircraft.
Flight 3 that returned about an hour ago had exceptionally good luck.
The problems of anti-submarine warfare are complex. Often the surveillance of a single contact may go on for days, even weeks, as information is gathered, interpreted, the course of the submarine plotted. The Tactical Support Center acts as a clearinghouse to train crews, store data, and coordinate tactics. Additional centers will be built as soon as prototype testing for this model has been completed. The existence of ASW facilities like the one at Patuxent will strengthen America's coastal defenses.
Test cell generally simulates flight conditions. It's purely a simulation.
The test center maintains a wide variety of ground testing and maintenance equipment. But most of the testing done here must be done under the same environment which exists where the system will be used, out in the fleet. For example, an engine can undergo extensive ground testing, but the true test of an engine's worth is its durability and performance in the sky. The test center is set up to answer that most crucial of questions. How well will it perform up there? To answer that question, Patuxent will use a technique known as accelerated service testing, in which an engine airframe combination will be put through its performance envelope on an around-the-clock basis with refueling done by tanker.
Time is money. It's important that we save time without eliminating some of the results, and airborne refueling serves this purpose. Of course, it's just another way in which we gain efficiency.
I can remember when we were first doing the flying qualities and performance on this plane. The center put it through rigid tests for every parameter in the plane's envelope. The test pilots who performed these evaluations are probably the best trained in the world, because in addition to the technical training of regular pilot school, there is fleet duty, then test pilot school, all before any test pilot assignment is made. And in some cases, test pilots return for a second tour following additional fleet duty. Like all test pilot graduates, these men have been given the knowledge and experience to talk to aerospace engineers in their own language. Actually, I first learned a lot of the basics about spin testing way back when I was in test pilot school spinning gliders.
The test center maintains the only gliders currently in use by the Navy. They act as good teaching devices to show students in the test pilot school how things really work up there. They are time expanders, like running a movie in slow motion, where you get a better understanding of air currents, wind velocity, and things like structural stability. Not only that, they are inexpensive both to buy and operate. But gliders are just a small part of the Navy's test pilot school.
The Hueys are sensitive, maybe a little more in yaw. It is difficult to put a pipper on a target and hold it. It's going to really be tough.
I really don't think it's going to be that much of a problem. As I say, it is just a matter of transition. And if you take a pilot that has ground attack experience, it's basically similar. The airplane, once it's in the ordinary flight mode is exactly the same as any other ground attack aircraft.
Yeah, but you're going to have dual qualified people. A guy that's going to have to.
Well, at the moment, there is.
Whether it tumbles end over end or backwards, etc. You get a look at about 3 of those.
Oh, when you think you're steady state, so I can time the...
Yeah, you can get some time from the outside. You can get a count on the turns, too. We get a good write-up on the evaluation for that.
At the school, prospective test pilots are given 8 months of the most rigorous, intensive training in aviation that the Navy has to offer. It's not unusual to see students working 15 or 16 hours a day in classrooms, in libraries, on the flight line, and at home to make the grade. And these are men who already have their wings. The training is so good, in fact, that many of the graduates, like myself, Pete Conrad, have been selected as astronauts.
Pump is armed. Air igniter is on, and hydraulics are on ISO.
581, this is TM. What's your altitude and airspeed?
Passing 12.5. Airspeed 325.
Okay, I concur down here on TM. Would you uncage the gyros, please?
Roger.
Okay, stand by for the spin checklist. Control augmentation cutoff is off. Chute is armed. Emergency hydraulics are armed. Auto ignition is on. Hydraulics, isolate. And the trim is in.
Okay, your turbine inlet temperatures look good, and I would say we're ready to go into the spin.
Camera's coming on. Okay, here we go. 38,000 feet, right turn. Checklist is complete. And there we go. Okay, let's spin, babe. Come on. Okay, I think we're going now. Why does it always want to go on its back? That's uncomfortable. About 1.5 negative G there. It doesn't look like it wants to spin. Let's keep it in. Come on, we'll have to shift loads. Okay, coming out. Okay, checklist is complete. In the turn, speed brakes are out this time, 60 degrees. Shooting for 2.5 Gs, and here we come to the left. Winding up a little bit, picking up a pretty good yaw, just like the book says. Look at that nose attitude. Okay, let's spin, come on. Controls are in as hard as I can hold them. Now it's looking a little bit better, coming around. This looks pretty good. Clint will love this. Goes on its back again. Oh, the forces are really high. We've got to fix these straps. In the turn, and look at this buffet. 30-degree brakes. I think we might get a spin this time. And on the back, oh, that hurts. I could do without that. Still doesn't look like it likes to spin. We'll have to try 40-degree brakes next time. Okay, let's hold the controls and keep them in now. Still looks more like a dance to me. I wish this thing would spin steady like other airplanes. Okay, recovering, brakes retracted.
Okay, everything looks good down here, 581. I say we're ready to go home.
Okay, coming up.
To get around this problem and thereby giving you a long and straight away.
Well, if we do It's going to put us spinning over the water again. I'd just as soon keep the spin point where it is, right here, over land.
Today's spin tests prove successful. Tomorrow, the results of this testing could save the Navy valuable time and money, perhaps even some lucky pilot's life. The test pilot and engineer may continue the post-flight evaluation and pre-flight planning long after their contemporaries have gone home. Many of the center's projects come to a close at the end of the day. Many do not. Some work, by necessity, will continue deep into the night. For a test port is like any port. It thrives on activity. Activity is the lifeblood of the test port.